Welcome, I'm Bill Wake. We're here working on a programming language called 10th. It's an imitator of 4th. Lately, we've been working on the interpreter and compiler, and I think we're mostly done with that. We'll have a few things to do yet, but for the most part, we're going to work in our language for a while. I say that, and it took about 5 minutes yesterday before we went back to the old style. Okay, so let's see. A loose end yesterday, we said, maybe we should use pound sign instead of a backtick for a comment. It's pretty common in Bash and other shell languages and some programming languages to use that. So let's take a look at that. And yeah, we'll be back in assembly language level. I think that's in IO, did we decide? .s. Well, there's our raw mode. Maybe it was input. Kind of not clear what the difference is it? Okay, read line, yeah, read word. Okay, so, well, one thing, well, that's in here, and it's a couple places, here and here. But I think let's refactor slightly first. Oh, let's run our tests and make sure everything's green. Whoops. Okay. Good. Okay. So I'm going to work on this. We'll call it a comment marker. And same thing here. Okay, but I'm going to pull this out and make an equivalence for it. Not sure where best put it, but we'll put it here. Let's say comment marker OX60 backtick. Okay, and now let's put this in instead of the two places we already had. Now the others, I'm less inclined to make the constants for these. They're pretty standard. It's a little, I don't know, it takes a little thinking, but this one was clearly egregious and it's a decision we would change. So clearly because we're changing it. And I'll just run input.tests. Okay. Let's change that word backtick. We need input tests. Comment marker creates comment end of line. Yeah, you can see we embedded that pretty tightly, didn't we? Well, let's change some names here. Let's call this commented line. Sorry, I didn't pay attention to the name. Commented line. And backtick empty. Okay, I think we got the backticks out of there. Okay, good. Okay, and let's change that now. Okay, so the test should fail. Okay. It found this as a word where we want to make that the comment marker. But if I've done this right, this is, well, I don't know. What is it? It's I probably should have this printed on my wall somewhere because I seem to keep checking it. Okay. Pound is 35 decimal 23 hex. And there we go. Okay. No, sorry. Got your comment a little slow. I think I get about a 10-second delay sometimes. All right. Good. Well, that's an easy to do. Okay, and let's move back up to our language. Put this over on the left. All right, so we left off, we're trying to write this string comparison, and it ends up putting a lot of stuff on the stack to make sense of it. Oh, let's change this before we forget. We're going to change backtick to pound sign. Okay, so it takes a lot of stuff on the stack to get this ready for this loop. The loop while test consumes the first three, and then we need, we don't really need the next three for the loop, but we do on the way out. And so I think what we want to say is when you get here, what you have is, let's see, you've basically got this again. Okay. And so we're popping off this one, and then we're keeping this, comparing this, and then we're popping off these. Sorry. Is this right? I think I have a hornet in my room. Okay, that's a little distracting. Okay, so we definitely come into the loop with this 1, 2, 3, 4, 5, 6 characters, 2, 4, 6 characters, and 2 strings. The strings are probably, well, ideally empty. Pop and compare. Pop pop the first one, compare the next two, pop the next two. I think I left off a pop there somehow. Well, I think here, just to be clear, it's really S1 prime, S2 prime at this point. Okay, so we get all that stuff done. I don't know. I really need, well, if I've got that many, right? I've got 3. I really need to, I can pop 4 times, I think. And then I still have 2 characters to compare. Okay, so that leaves me, C1, C2, C2, C1, C2, C1, S1 prime, S2 prime. Okay. And that's fine because I need to equals, and then I'm going to pop those 2 things. Same here. All right, now I think we can do better because equals leaves a 1 or 0 on the stack. So if I can work out a way to leave the 1 or 0 on the stack and pop the next 2 down, well, I think I can. Well, the easy way, at least, okay, I've got 1 or 0 on the top of the stack. If I do CBA, that reverses them. Or CAB, it doesn't really matter because I'm going to pop them. Pop, pop. Okay. And then this if goes away. Okay. Now, it feels like we have, like, is this second dupe 2 really necessary? We spend a lot of time popping it. All right, but I think, well, the question should be, does it work, right? Now, am I going to do, it would be nice to do a real test for that. Yeah, we need to get that under control, right? So let's make a test. All right, now this one, I don't think we're ready for test title, but let's make test empty strings equal. And this is, well, if I push an empty string and I push another empty string and I call equal $, I'm going to make a simpler assert equal that's just numbers. And this one I haven't defined yet. Okay, so now I want to say if, well, I have x1, x2, A and B are on the stack. I want to assert that B equals A. So I'm just going to call equals on them and then do an if. If that is true, well, actually, I think we want to do more like JUnit and not print out stuff if the thing passes. Okay, so let's say we're going to do this. If it's not equal, then we need to do a warning. Okay, so that tells me I need to do a dupe 2 as well. Dupe 2. And then I guess it doesn't matter which one I do because I got to go down both paths. else. Okay, so I'm coming in with A and B. I'm going to duplicate them and check them. So I still have A and B on the stack, so I can print them if I need to. Well, if they're there, it's pop pop because we don't care. We're just getting things cleaned up. If they're not there, then we got to do some. We need to print a message. And well, I think we want to say error values differ. A equals. I'll print that. Then I'll print the first value. Oh, I'll print it and pop that. Print the first value. Then print /n b equals print pop print I guess I could print and pop him, and then one last bit of our message /n $pop. Okay, do I trust this? Okay, we come in with two values, we duplicate them, we check if they're equal. If they are, fine, get rid of all the evidence, pop. If they're not equal, then we're going to say error values differ, A equals, and then print that, pop the string, print the value A, pop, print, push new line B equals, print the string, pop it, print and pop the next value, and print the trailing string. And we push three strings, we pop three strings, and we pop two values. So we're equivalent to the other one in terms of the stack. Always a good thing to check. Okay, so I think that kind of works. Well, let's do a quick test on that. Test assert equal when equal. Well, no, I can't do a check like that, because it prints, and I don't have a good way to check prints. Okay, I guess we checked that manually last time. We'll do it again. All right, so I'm going to take this. Dupe2 is ours. Let's run our REPL. Oh, okay. We can overwrite those. Okay, so let's go down here to assert equal. Oh. And yeah, I keep doing that. Fee. Okay, and so if I say 1, 2, assert equal, values differ. Oh, my new lines didn't new lineify. Why is that? Oh, because I don't support that. Okay. Yeah, we made new line. I don't know. This may be another sign of a lack on our part. and I'll print a new line. So I've basically just assumed we'll do that. Okay, so dot dollar print it, new line, and then I'm going to print, we gave it 2 spaces. A equals dot dollar pop that, print that, new line, new line. B equals pop new line. One, two, assert equal. Values differ. Okay, something's weird. We missed a pop. Excuse me. All right, sorry for that. All right, you need to pop the error string too. Oh, yeah. Right, everything printed should get popped. Yeah, maybe. We'll see. Okay, so let's take that. There's a good reason we want these assertions because it's so easy for me to make mistakes. All right, 1, 2, assert equal. Values differ. Okay. 1, 1, assert equal. Doesn't print anything. Okay. Yeah. Yeah, we'll keep that. It might be worth doing that. I'll leave it. And if it just comes up more and more, strings, I guess it's kind of under there. Dot pop and dot pop dollar. I don't know, whatever, by some name. Okay. It's certainly a common sequence so far with as little as we've done. Okay. All right. So I kind of trust assert equal now. And given that, I should be able to check my equal string. And then we're going to go back and see if we can, well, I don't know. I feel like we could do better, but I also kind of want to move forward on things. Head to dollar not found. Okay. All right. Word not found and. Did I use logical operators? I did. Okay. So, that's equal dollar. Now let's assign, let's, Oh yeah, you got to define things before use. You can be recursive, but you can't be mutually recursive. Okay. All right, so if I run tests, that should run this test and it should print nothing. Okay. Now, let's make the next test. Test strings different strings unequal. And I don't know, I think I could stand this as a one-liner, I think. Oh, this didn't do an assert. Okay. Equals equals should be 0 or 1 on the stack, and now I should be able to say assert equal. They should be a 0, assert equal. Okay. This one, this should be 1, assert equal. All right, let's pull this into one line. Okay, I run tests again. Both these should pass. Okay, values differ. Well, we don't get our test name for free, do we? That's annoying. Test different strings unequal. Empty strings equal fails. Okay. Nothing equal dollars should be 1. So that should leave a 1 on the stack and a 1, and the assert equal should be happy. If they're equal, pop, pop. Okay. Well, okay. I guess that means we got to look through this a little bit. Okay, head to put C1, C2, C1, S1, S2, or some combination. Dupe2 duplicates the 2 characters, and then once again duplicates the 2 characters. Okay. While equals consumes the first 2, equals 0 consumes the third, not is the third, and then and, well, those 2 pushes their equals 1, that not just deals with the last one, and so that chews off the first 3. Okay. Now what we would like is, oh, now wait a minute. That consumes 3, right? So when I come down here, I have C1, C2, C1. Oh, yeah. Okay, because the while consumes 3. So it had that at the end. Let's make a note of that. Okay. But yeah, so the do goes back and runs the while, and then the while. I mean, I think this is probably interesting for the while. This is what the stack is going in, and then pop, pop, pop. Well, is that right? C1, C2, C1. Okay, so it consumes 3, it leaves 3 characters and 2 strings. Okay. Pop, pop, pop gets rid of the 3 characters, and we're left with the 2 strings, and we're fine. Down here, we got C1, C2, C1. Pop, 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 pop is too much. And, oh no, it's way too much. Because we want to leave C1 on. We want to leave 2 characters on C2, C1 so we can compare them. C2, C1. Okay. Yeah, I think that's better. Then we'll put the result on top, and then S1, S2, result to the bottom, and then pop those 2. Okay. Let's try that. So that's kind of weird. We're not found wow. Oh, we probably destroyed something. By going in somewhere along the way, we were grabbing stuff that was outside the range of the stack. So I think I'm not sure why while would get trashed. Yeah, really not sure, but I'm gonna exit, rerun. Okay, now we gotta redo a bunch. Well, I guess all this. Okay, there's assertEqual, then our 3 tests. Okay, now if I run tests, good. Okay. It's possible. Yeah, it could well be possible that we're running out. I don't remember how much we left. Secondaries. Oh, where did we put the interpreter? $20,000. That seems moderately enough. But on the other hand, 200,000, 2 million, that seems like more like it. I think it was not. I think it was more of a stack issue than a memory issue, and this may be. It may be the environment telling me, "Hey, you ought to be checking those stacks, for underflow and overflow." Yeah, so 2 million eight 8 byte quantities. Okay, so yeah, that's a lot then. We can't blame that anymore anyway. Okay, but the tests seem to pass now, so that's pretty good. Let's I want to organize a little more. So I don't want this to be tests. I want this to be like test strings, and then I'm going to have a test all that definitely calls test strings. Okay. So get that much in there. All right. Now, okay, and we should do assertEqual dollar while we're kind of working on this. So it's going to look a lot like this, but it can't be the same, unfortunately. If we had typed or tagged our types, we can't tell when we're looking at the stack, should it be printed as a string or as a number? Okay, so I don't think we also don't have we don't have the equivalent of a closure, so I can't define something that's some operator that I'm going to call and then just call it. We don't have that mechanism, which means we're going to have a little more duplication than we might otherwise. But here, let's say string values differ. A dot dollar dot, that's string and string. Okay. Now I don't know if there should be a way to do that. Indirect, like some sort of indirect procedure call or function argument or closure or something on those lines. Again, I think we'll just see how often do we run into that. We could add, we could add something that lets you call a string and make a variable out of it that does a function or something like that. I don't know, maybe, but I'm going to not do it. I'm just going to do this, and let's add assert equals. And if I say empty equals empty, yeah, assert equal dollar, that should be true. Oh gosh. Okay, did I get them backwards? Dupe2 equals dollar. All right. Yeah, I think I can live with that. Oh, thank you. All right. Good enough. Okay, empty strings equal. That seems okay. All right, and then I can do a little separator and this. Okay, I think we've got the test framework now. We got a couple extra verbs. I think I'm ready to do something on our app. Okay, so we got those two done. And also we did assert equal. Okay. Now so I'm envisioning, let's see, my picture went away. Here we go. I'm envisioning the word hangman at the top, and then the guesses, then the scaffold, then the body, then the guess. Okay, so I'm going to check the pieces, and then we'll need to add some screen stuff because I want to position it in a certain way. All right, so the simple test, it's almost too simple, really. But I want to make sure that when you call title, you get Hangman. Okay, and so to do that, we have to have title to find. Let's do this. Okay, and now I think I can. Let's call this test Hangman. So far, it just has test title. Okay. All right. And if I say test all, something. Oh, darn. Okay. I didn't call test Hangman. But I can call test Hangman with what I have now, right? Yeah. Okay. Test Hangman. Oh. Oh, wait. Assert word not found to assert equal strings. Yeah, that's true. This is assert equal dollar. I kind of changed it somewhere along the way. And I think I need to repeat that test Hangman to make sure it gets the right test title. Okay, so test Hangman. Okay, good. I can easily do that. Okay, and all right, nothing wrong. Okay, and then I think the Hangman app. Let's just define Hangman, the app, and what I want to do is print that title. All right, so I'll do title and print and pop. Here we are again, wanting that. I don't know. I don't have a good symbol for pop. We don't use arrow for anything yet, but they're caret. All right. Okay, so let's make our own definition. Dot dollar. I don't know. Is that pop? What were your other suggestions? PP dollar, dot dot dollar. I'm going to go with the symbols. I may regret it. Dot dollar pop. Okay. Actually, title and new line. At least for now. Oh, yeah, I got to define that. Okay. Version 1. All right. Now I want to get into stuff the screen should do for us. And so I think there's another section of our application. And this is strings, screen things. Okay. And so I don't know. Well, I somewhere have a link to VT100 stuff. Let's go dig that up. Okay, so, well, no, so we definitely have this that lets you position at home. There's another one for a cursor to a position. I don't see it. Force cursor position. Oh no, that's home. Oh, if it's provided it. If no parameters. Okay, yeah, so this is really cursor move. There's a clear screen somewhere here. Erase screen, escape bracket 2J. Okay, so, well. Yeah. All right, so I guess this is more of a, well, let's define escape is 20, no. Escape is 27, but oh, is something, am I getting that number wrong too? 20, no, 27 decimal anyway. So somewhere I have to print an escape character. Okay, so I'm going to print, I'll do it this way for now. 27 print pop. I don't have the other one. Okay. I don't have a mechanism to do this yet, but I'm gonna push it off. All right, and so I'm gonna do escape, and we'll pretend we can solve that problem, and then bracket 2J, print string and pop. Okay, so if I could solve this, I could get my terminal sequence going boop boop and erase the screen. Okay, so that's possible. I guess the thing I don't know, well, we don't have a good way to print a character yet. The way I have, okay, we need to define array to array escape. I think that's that. So we got well, let's call it init screen. Actually, I want to call it init escape. And then see what we do for these. Somewhere of memory. Okay. at equals. So if you have the address and you hit memory, that's what that's saying. Okay, but our array, a array name, and then a plus equals mem sub c sub b equals a. Okay, so mem sub c is the array, index 0 equals 27. Okay. And at plus equals, right? Yeah, so memory sub C sub B equals A. Okay, so memory sub escape sub 0, first word, equals 27, at plus equals. And then now we have, well, I guess I want an escape. Okay. And it escaped that way. And then I want to define escape. I think it was just var, right? Variable. Escape. Well, I almost want this to be my escape. Okay, so that should create the escape character. Yeah, I want to use make dollar. Yeah. So make dollar makes the string at equals. Okay, so I want to push escape make dollar at equals. Is that going to be right? Okay, so escape pushes the variable on the stack. Make dollar turns that, well, init escape, well, I should do the whole thing in there. Is that going to do it? All right, so we wrote the variable, we wrote the number into the variable. We call make dollar. Now that string gets pushed. No, then we push. Okay, that doesn't push anything on the stack, does it? At plus equals. It does the assignment, but it doesn't bring it back. Okay, so I think we have to say variable escape. Let's call it array. I want to mix these things up. Okay, to array, escape array. So now we put escape array there. Then we take escape array make dollar. And then I guess I want to put escape variable, escape array make dollar. That should turn the variable's address should now be set to the pointer to this. Is that right? No, it's not. Escape array. Oh, yeah, escape array make dollar. So this pushes the variable's address on the stack. Escape array make dollar turns that array we just built into a string, and then the assignment saves the string address into the variable. Okay, and so my escape then is $arrow. Okay, let's see if this works. Okay, so if I print ESC $, it should print an escape sequence. And I don't know if I can tell. Okay. Oh, I haven't called init. Init escape. Okay. And now if I call screen clear, let's see if that does what I want. P2J. I think at plus equals array assign and at equal is variable assign. Let me check. Yeah, at equals for variables, at plus equals is for arrays. Okay, so the variable is set to 0. Let's make sure that's quite right. Okay, so we create an array of 2 characters, 2 words, and then we create a variable escape that I want to hold the address of the string that we create. Okay, escape array 0, assign it 27, knowing that's escape. Add plus equals. So that should set the first byte or the first word of the array to 27. Then escape array should push, ESC should push that on the stack. And then escape array is the array address, make dollar should turn that into a string. And then add equals should assign the string's address to the variable. Okay. Yeah, why did I get a P? That's a real good question. Let's try it again. I don't know. It may have been because I printed an escape once already. No. Okay. Escape print bracket 2J. Let's make sure that sequence is right, but it's the escape that seems to be the problem. Now, I know what we can do. We can call escape head. Okay, let's try that. Escape head dollar. And then print the top of the stack is 80. Is that P? Yeah, okay. Init escape array 027. Okay, let's look at escape array. Escape array 0 at plus print 27. Escape array 1 at plus should be 0. Okay. So escape array make dollar should put the string on the stack. Head dot head dollar dot. What? Okay. As far as I can tell, escape array looks right. It's got a 27 and then it's got a 0, and the make dollar, well, if you call head dollar on it, you get the right 27. Okay. And then let's do a pop and print dollar. empty string. Let's redefine screen clear. Oops. Okay, so if I just print the escape, which should be a string, well, I don't think so because we had this. Oh no, wait, that tells me that. Okay, let's do esc dot. That gives us a memory address. 33224. Yeah. I guess I'm suspicious about our print. Could it not be handling unprintable characters? But we've had new lines and we've had tabs, maybe. All right, I'm going to back up. So in this, we create the array. It's got two integers and a variable escape that could be whatever variable. We set the first character to 27. The second character is already set to 0. We assign it, so it's set. Then we bring in the ESC's address, and then we call escape array, which brings this address back, and make dollar gets called on the array. That leaves the variable name address and a string on the stack, and then add equals assigns the string to the memory the variable address points to. So ESC should point to a string that's that. Okay, let's change it. Okay, I'm going to do it again. Init escape array 0. Let's put in 65 A B C D 6 7 8 68. Is that D, capital D? Print is using the syscall. Gosh, you wouldn't think write would have a problem with it because like everything that gets written is going through that. But okay, so I'm going to try and do this. I'll make it 65 so we can see the A is always understood. ESC escape array make dollar at equal. Okay, and if I do init escape, I should write an A in the front of that array, get the address for ESC, get the address for escape, do make dollar, turns that into a string. At equal should store that string into ESC. Okay, so if I do ESC head, I should get an A. Stop. ESC head dollar. Now, bizarre. Oh, I don't have my editing keys. Okay. Now this is weird. Well, this is we have this asymmetry that make can create strings, but we don't have one that's like, I don't know what you'd call it, but we don't have something to go the other way. Do we have that? If it worked, I wouldn't care, I guess. But ESC, wait a minute, ESC head dollar, it always pushes something on the stack. ESC dot dollar question mark. Okay, let's go into that print. Is that u dot print string? Okay, so yeah, it's pretty minimal. I mean, it's taking the string at the top and printing it. No, I mean, write should take a character buffer and shove those bytes onto the screen. Because I mean, it's C that has the backslash thing in it, right? So the write is really primitive. Unix functions. Where's did we not do it right? Did I cheat on that? Oh, wait a minute. Let's find our print again. Not input. Dot print. Real print. Where's print? Oh, well, that thing should have probably done that. Okay. All right. So it's calling the Unix call. This is the Unix write. One is standard out. Okay, where is he getting it? X0 port number. X0 is input address of zero terminated string. Okay, and we turn it X0, X28 holds it. We write this, compute the length into X0, store that as X2, store the address of the string as X28, and then that. I mean, that looks pretty simple. Okay. So, I mean, our print string, dot print string, it just gets something into X0 and prints it. Okay, so where's our playground? No, it's in test. Test playground. Okay, so let's make a escape sequence. ASCII Z. Now, does this do this? /E bracket 2J, was it? Bracket 2J. Okay. And if I call BL print, instead of in a raw mode, and then exit. Okay, so you do a load address. X0 is L escape sequence. Well, actually, I'm going to take the L off so I can watch this thing a little easier. Okay. That feels like one that should do its job. Make I don't know if our make file, I don't remember. Oh, make playground. Okay. Demo.s needed by demo. Do we never do this? Unit test playground.o. Oh, there is no more demo.o. How do I get a darn escape character in there? That is right for C, isn't it? No, they don't have one. Okay, I can do OX, what, or /X, or /DDD. 27 is 1 something, 1B. Okay. \X 1B. All right. Okay, that part's good. It cleared the screen. I mean, that's progress. Okay. So what the heck is going on? So we just gave that thing a string. You know what? I'm about ready to just make just like we made an NL, make a ESC. Let's do that. Do we want to print it? Yeah, local address. Thank you. Okay, so Prolog, load the address of this, print that, exit, and define this in main. There's this. Let's take that one out. Where's my... There it is. And global. Okay, let's do a make. Okay, and then back to our 10. ESC no longer needs to print and pop. Just temporarily. Good. Okay. Feels better. All right. Now, let's commit what we got so far. We're adding... Okay, I guess I should be committing off our playground more, or off our 10 file more. Okay. Now, so I want the game, well, at least this much. And then I'm going to put some more new lines in there. Okay. Now I think I can do everything in here. Ah. Ah. Why? Oh, my screen clear. Did I change it? Why would that work? Well, it should print, escape prints right away, and then this should print. And sorry if I did screen clear. Oh no, that's not working now. Did that not work a minute ago? Screen clear. $pop. Oh, yeah, you're right. This is no longer needed. Okay, so let's, I think we can try it like this again. Hopefully overwrite the right stuff, otherwise I had to restart. Okay, so screen clear. No. All right, let's quit it. Make REPL. Paste all that. Screen clear. Oh yeah, there we go. Title. $. Hangman. Okay. Woohoo. All right. So how do I want to print it? Okay. Now there's modes. Oh, let's get the VT100 thing back. All right. So this, I mean, I definitely can do this and force it, put it at a certain place. So I want to print Hangman, halfway across the screen, or, noticeably across the screen in row 1. Now, somewhere I'm pretty sure there's a way to say I want relative positioning. Let's see. Is that in here? No, not mentioned. Well, I may be wrong on that one, but I could have sworn there was something to do that. But that's okay. No, that says it. Okay, maybe it was a VT200 thing or something. Not universally supported. All right, but we can position to. Okay, let's do that. I'm going to say screen move to. Yeah, if we set it home, then everything will be relative. All right. And we're going to have, I guess we'll say the stack is going to be column row. Does that make sense? Maybe the stack should be row column. All right, and that should be escape. Escape bracket top is row. Print the bracket, print the escape, print the bracket, print the number, print a semicolon, print and pop, print the next number, which is the column, and I got to check the order now. Row, then column. Okay. Print that, and then print H. Dot print dot pop. Okay. I think it's 1 based. All right. So I'm going to say screen move to row column 40 row 1. Does that seem right? I think I want it the other way around. 140. We'll swap their order. Okay. 140 screen. Move to that. Okay, so let's take this stuff. Okay, and if I say Hangman, I want to show up further down the screen. Ah. Okay, it did the screen clear. Oh, escape. Dot dollar. Yes. Dot should be, well, if I give 140, then I should have 40 first, then 1. Okay, I push row 1, column 40. It comes in and swaps them, so it's 40. Sorry, row 1, column 40. So it's 40, then 1. I swap it, it's 1, then 40. I pop. I get the first one is 1. Okay. Let's take out the escape. Do I have enough stuff? No. Okay. Boom. I don't know. Okay, we push this. Oh, we swap the row and column. We push a string. We print it and pop it. We print the value on top of the stack and pop it. Print a semicolon. Print the next value on the stack. And then pop. Okay. We'll do it manually. Okay, so 140. Okay, and then we'll do swap. Let's go this far. Uh, 140 swap bracket dot dollar pop. It's the equivalent. Prints the bracket. Okay. Then dot pop. That should print the 1 semicolon. Oh, I don't know about those spaces. Ooh. I don't know why it crashed in this one where I took the escape out. It should have just printed that stuff to the screen. but yeah, one space is a problem. Okay, I think that's probably the issue. I don't think I can just type it here. Escape bracket 1 semi 2 H. No. Okay. Well, tell you what, let's take a break. We'll come back. We'll see what we want to do about that. I know it's been so handy to have those spaces after the prints with the things. It's almost always what you want, but it's not here. I don't think. I think that's the issue. Yeah, let's take that break. 3 or 4 minutes and we'll come back and tackle this. All right, welcome back. Yeah, let's try something on those lines. See if we can make that work with strings, and then we'll worry about the rest of it. So, if I do 140 swap bracket dot dollar pop, I didn't. That arrow one is defined otherwise. Okay, that gets the first string. Then I do dot dollar pop gets the 40, no, the 1. And then I do semicolon dot dollar pop. And then I do dot dollar pop for the 40. And then H. Okay. So this should go to the top of the screen. Well, that should position me in 40, and I'll push hangman dot dollar pop. Okay. So hopefully this moves up to the top of the screen, line 1, column 40, not going to be halfway on a big screen like this, but somewhere not in the left-hand column, and print that. Okay. Oh, I left out escape. I guess the good news is that's what we're going to print, and that's what we're supposed to print. So that's a good thing. Okay. Escape bracket dot. I should be able to just take the rest. That's ache 40 question mark. I don't know. I must have bumped something weird. One 40. Oh, no quote mark. What's that? Escape bracket dot dollar pop dot dollar pop semicolon dot dollar pop dot dollar pop H dot dollar pop testing dot dollar pop. Okay. We got testing up there up top. It's kind of weird for our thing, but that's okay. We could do a clear screen or something. Okay. Yeah. All right. So let's fix this thing. So screen move swap escape bracket dollar pop. I want these things to be computable at some point. So I think it'll work, but we need to. I want to fix it. So I'll change this to dot dollar. Change this to dot dollar, and that should do that. Let's do this. Grab all this. Paste all that and run hangman. Oh, what's this AKE? Oh, is that my... I don't know what that is. So clearly it's getting there. Now, did I leave something out? Oh, I did. All right, make rebel. If I paste all this and I call screen clear, that seems pretty good. Now I should be able to do this. No. Okay. Escape. Dollar pop. Oh no, escape prints its own. Okay. Escape. Print. Swap the two arguments. Fine. String pointers. Print the escape. Print the bracket. Dollar arrow. May as well use these while we got them. Okay, escape bracket. First argument 1, semicolon. Second argument 40. What's this one? Oh, sorry. Escape bracket. Print the bracket. First argument, semicolon, print that. Second argument, print that. Then the H and print that. I'm puzzled. I don't know what. I think it's probably consumed something. Like normally, well, I would expect to be make maybe. Because I ran make REPL. Let's just run ./REPL.out. Do the whole thing. Screen clear should be good. Okay, so yeah, it was make, something's consuming it, but when you do these terminal mode things, you definitely, probably gobbled up the first character, yeah. But what's bracket M anyway? No, don't see anything. Okay, that's okay. Well, I guess I'm going to try one more time and then we'll bring out the debugger. Do all that. I'm not going to call screen clear first. I'm just going to call the 140 screen move 2. Boom. Okay. It feels like just on our debugging list, like it would be nice to be able to print, like examine screen clear and have it tell back to me what it thinks it has. I don't know why this is. I don't know how it decided to space things out like it did. Okay. But let's do 140 screen move 2. Okay, yeah, we expect to be in start 2D. All right. What are we looking at? All right, let's see what x0 is. 3b. Yeah, basically just dump the structure of the secondary. I mean, that would be a nice tool. Let me add that to the list here. Um, thought I had some already. There we go. That's a debugging. These are all like debugging. Yeah. Okay, but x0 should be the, well, something went wrong before we got here. Let's see, what's 3b? Do I still have a calculator running? No. Well, 3b is 48 plus 11, 59. Oh, I've got my ASCII chart right here. 3b is a semicolon. Let's check our definition somewhere around that. We definitely put a semicolon in. All right. I think this is going to act weird. Okay. Dot dollar. No. I mean, it's almost like it got a semicolon in there in the word it was looking for. I didn't know if this threw it off. Like if it found it was in a definition mode and found a semicolon, is that all right? Foo is semicolon dot print pop. Boom. Huh. Okay, let's do it again. Colon foo x dot dollar pop. Huh. Foo. Yep. Yeah. But it shouldn't. It shouldn't, right? Because it's in a quoted string. That shouldn't be a terminator for the string. So let's go find, I guess, input. No, it definitely shouldn't. I mean, that's weird. All right, where's read string? Okay. All right, so we skip past the first quote. We move. The result is going to be this word that we're on, the first character inside the quotes. And then X1 is string found is our constant for that. Okay, so we get the next byte, and if it's a quote, yeah, Did we check that? If I did, oh well, okay. Do semicolon print pop, and it works. Okay. But I'm very puzzled. I mean, I would say this. He gets the next character if it's equal to a quote. Well, wait a minute. If it equals a quote, he exits the string. Otherwise, he goes back for more. Now, what happens after read string? Because maybe he's left things. Look for string. Okay, we find a double quote, read string, and then we exit word. Store a 0 at the character. Well, okay, let's just make sure longer strings, right? AB dot $pop. Yeah. I mean, that loop looks like it just goes until it hits that double quote. Now, have I missed a quote again or something like that? That would certainly screw it up. That's in quotes. That's in quotes. That's in quotes. How? You enter compile mode and try and print a semicolon. Well, that's this one, right? We get our make now. I'm super puzzled. Oh, is it looked up in the dictionary first or something? I mean, exit string, the current character is a double quote. So we we got in here. We call loop for string. We call read string, and then we exit word. And that says store a byte at next word -1. But we already skipped past the quote. So the pointer is pointing to the byte after the double quote. Yeah. I just don't get how come that matters. Okay. Oh. Well, it certainly looks for this in the compile mode looks for that. Let's go find colon. Okay, he calls read word. That gets the foo. He puts a pointer to start 2D. Good. Changes to compile mode. Okay, so we got to go back to our, I guess that's REPL. Compare to compile mode. Okay, if we're in compile mode, yeah, I think you're right. So maybe it's not paying attention to like that second flag, right? X2, X1 is the type of the word. So if it's a quote, he certainly shouldn't evaluate. I don't know what he's doing. Oops. Okay, so if you're in compile mode, go to evaluate. Otherwise, stay here. Get X0, X1. Compile. We got the word type. Okay. If the word type is string found, he should be coming in here. Okay, so we're going to catch, what are we going to look for? We're going to have to stop at compile. Okay, and we expect to see the semicolon with string found being true, or the number being string found. And then we go to compile string, otherwise exiting compile. Restore the variable and return. Yeah, so that seems okay. All right. Well, that's, yeah, I mean, it should just call this. Let's peek at that too. X0 type pointer one sat. Okay, so compile string. This is the one we just did the other day. Push the word address, store X2. And we don't reference X2. Do we reference X0? Oh, right. It's still in here. Well, I guess we're going to look at compile string. Where all we should stop. And I suppose we should look at REPL. Excuse me. The main REPL loop. Okay, eval all. Yeah, so we saw colon, we'll see semicolon here. Okay, so basically it writes the N2D and returns to run mode. So I think the relevant code is probably that isMeta check that we saw. Oh, that was in colon. No, it was in REPL. Right, eval all. What's that? isMeta. Right. So if it gets here to calling isMeta, then I think something's wrong because the semicolon is in the isMeta list. So we're coming in here with well, let's just run it and find out. But x0 should be pointing to a string that's just a semicolon followed by a 0 byte. X1 should be type string. Now, it may be something didn't get restored right, or a pointer not moved forward enough. Switch to run mode cannot happen when string found. I don't think it can, but but it does, right? Reality kind of wins the arguments on that, but I certainly didn't expect it because we checked right away. Oh, well, no, we're checking compile mode. Oh no, maybe isMeta if it's semicolon. I think you're right. I think that's what's doing it. We're checking compile mode, but we're checking isMeta. Let's go find isMeta. I swear it's somewhere else. I'm not thinking our organization is so great. All right, let's find it. Okay, search for the string in the meta list, right? And that's going to find it. So let's find the meta list. That's in main. I would expect it in main. Right. Yeah, so these things say they're meta or not. Okay. Repeat until if do while. Okay, so I think what that tells me, I think you'll have the same problem. Now, odd pops stuff off the stack, so it's going to fail. It's fine like this. Prints odd, but if we do foo odd dot dollar pop, which won't get executed, semicolon, right? I think we're going to define, I think odd is going to get detected as a meta. Well, no, the thing is, strings get treated differently for at compile time and at run and evaluate mode. Okay, let's see if this blows up when you run foo. Okay, yeah. Okay, so it's the fact that it's a meta. Yeah, because let's see, is it compile? Where do we put our string stuff? Was that an input? So read string, if you're in evaluate mode, it puts the string in secondary space and puts the pointer to that on the stack. If you're in compile mode, we did all that stuff where we jumped around it. So they do get handled differently, but compile needs to, it should not call isMeta on a string. That's definitely definitely wrong. Where's colon? Okay. No, it's REPL. Okay, so where's eval or whoever checks that meta thing? Eval, yeah, right. So if the word is meta, yeah, it can't. it can't call this meta thing when it's looking at an X1 type. X1 type has to be, sorry, X1 has to be word for this to make sense. If it's a number, well, okay, we don't have any meta numbers for sure. We have meta words that are, or we have words that are. We had 0 and 1 in here at one point. We still do. Okay, we don't need to, but they're not meta, so they won't show up there. But I think the deal is eval all. It can't just take whatever it gets and do meta. It's got to make sure its type is X1, right? So I think if it's meta, it goes to evaluate, but we need to make sure its type is, well, you could call isMeta on it, but the real thing is, yeah, I mean we can work around it, but the real thing is the strings are getting mistreated, misevaluated. They're being treated as potential meta words, like my OD one, right? So I think, I mean, this is a bug. It's a little subtle, but I think the thing is, if you're, oh no, it's not a. Is it that if you're meta, you should evaluate? But if I'm already in compile mode, okay, if I'm in compile mode, then I check is meta. No, sorry, I get twisted. Yeah, that'd be a possibility. You're not a meta word if you're a string, right? Ever. Okay, so yeah, I think that's probably fair. Yeah, I think we can do that. I mean, it's got X0, X1 going in. It's they're available to it, and really they're sitting there. So yeah, is meta. I don't remember where that thing was, but dictionary. Right. Okay. So let's find the test for this. Okay. isMeta finds only metas. Well, I think we're going to make a check that says isMeta always false for strings. Okay. Well, dictionary init. Okay, let's just put semicolon in there as meta, and then we'll need the string. I think I have L colon string, L semicolon string. Okay, let's do that. That was ASCII Z, right? Okay. where did we define those names? Oh, REPL.macros, okay. Is this Meta's problem? I guess it kind of is. But it makes me want to move those macros somewhere else. Because dictionary should have access to it. Unix function, yes. Core defines, that sounds like a place. Okay. And dictionary test. All right. Okay, so this needs to get string found. And these should probably be explicit. Word found. Okay. Okay, so we got semicolon as a word there. This sets that and it calls isMeta. Okay, so. All right, so this test should pass, but this one should fail. That's dictionary. As I read. Okay, isMeta always false for strings? Fails. Okay, but we can dictionary isMeta. Okay, we can do lmeta end. Okay. All right, so if x1 Um, compare x1 to, it's really, does it have to be a word? Or is it string? Is string found is the problem? I think the way we are now, we'll allow numbers to be words and meta words, so we shouldn't worry about that. It really is the string that's the problem. X1 is to string found. If it's not equal, let's go here. And otherwise, we're going to do stuff and then branch to L isMeta end. Okay, so those get restored. That seems good. And then we're going to move x0 gets 0. So we fail. Okay, so okay. I didn't see the red, but dictionary. Okay. And hopefully this works. Colon foo, semicolon, dot $pop should define and should work. Okay. Let's save that. ACB. Make isMeta check for strings and always fail if so. This is today. Okay, make isMeta. Okay, but we also defined screen clear and defined first cut at hangman. Okay. Print hangman at the top. We're closing in. All right. I mean, I don't think we have bad tests on this stuff or anything. I think it's just a subtle thing. You know, it's partly if you remember, we added that string type versus word type thing. That was not there originally. So there was kind of a hidden consequence that it needed to check that for meta, but it definitely never crossed my mind that semicolon might be a meta and that would be the problem, you know. Okay, so now this should print hangman up near the top and not blow up. Okay, yay. But I think I would actually like it in row 2, come to that. Okay, but that's good. So it means our screen move to is working that way. I don't know what we got. 10 minutes. The thing that I might want to do, I could see defining a dot that meant print but don't give the extra space or something. You know, just kind of a weird little thing there. That space is so useful by default. It's hard for me to get to really eliminate it. And most of the time you want that. I really wish the VT100 had taken that into account, but maybe that's okay. So, I mean, to me, this part, the screen clear and that's sort of the IO of things. And then Well, let's go to our to-do. Okay, so we're going to draw, I think the scaffold really comes first, okay? Because this stuff repeats for each word. It's kind of like the scaffold can be there, but the the body gets replaced. Okay, yeah, let's draw the scaffold. Okay, but we did this, yay. And we're doing at least some work on Hangman. Okay, right. So I think we'll make a scaffold method. And I don't know what it's going to do yet, but it's going to have a job. Now, I think what it should do I'm trying to think in terms of a screen package that would like keep track of the cursor and stuff like that, but um maybe that's too much to ask. I mean, maybe it's better to say, you know, that is line 2, 3, 4, 5, 6, 7, 8. Maybe line 8 we start drawing this thing. No, I don't think we've chosen a word yet. I mean, we'll need one and all that, but I'm thinking let's just draw the normal start is you start with a scaffold, and I mean I guess you could start with the dashes as well, but we got to draw a scaffold. Um, yeah, I just want to print the gallows part. Um, is that a 10-minute job? Yeah, 7-minute job? I don't know. All right, but let's say so. See, I'd like the method to just print these dashed lines, print these two characters, print this, all in separate lines. And that's kind of what I want to check that I'm seeing. Now, how that prints, I don't know. I mean, would it be better to print? Like, what should I get back? Should it be dash, 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 new line, bar, slash, new line, bar, slash, new line, bar, slash, new line, bar? Would that be the thing it worked from? Or it's got to be an array of strings? We always thought arrays of strings would work. Maybe this is our chance to find out. Okay, so um, yeah, I mean, it's kind of constant stuff. I think the notion of saying, start drawing your stuff here at any given point. I tell you where to draw to, and you draw it in those relative positions. Seems like a good thing because same thing's going to happen here or body or torso. I think that's reasonable for it. You give me the address. No, I'm going to give you back the string or an array of strings. I'm not sure. But I could see giving you back an array of strings, and then when I tell you draw an array of strings, most things just have a simple string, but this one's big, and the torso is a little different. All the others are just one because so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 guesses. All right. Yeah. So let's say, okay, so scaffold. Well, I almost want to just say like row 10, column 35, scaffold. Or scaffold, draw. That's kind of what I want to do. And where, okay, we've defined scaffold, but then draw, well, it gives me a place to go. Yeah, so I want the draw method to, I want scaffold to produce an array of strings, and then I want draw to take these two numbers in the array of strings and draw each line starting, the string for each one of those members of the array, and then starting always in the given column. So move to this position, draw the first line, move down a row 11, 35, draw the next line, and so on. Maybe I just need to comment where I'm thinking. We don't have a lot of time. So it's given a row, column, well, I mean, it's really the stack. I don't have a good name for this. S colon is scaffold, column, row, etc. Should pop all that, but draw array of strings, one per line, starting in given column and row. Okay, and then so it takes all three of those. Scaffold returns array of strings. I think I could see an argument for a string if we had more facilities, but array of strings with an empty line at the end or something like that, or a count and an array, but I think an empty line, empty string last. But it's awkward to create those, so we'll have to think about that, right? Because you'll have to go build that array up, which feels very awkward to me. All right. Well, thanks for joining. I mean, we made a little progress today, less than I hoped, I guess, but we fixed a couple things and we got the screen drawing. Just the fact that it can kind of place itself on the page is kind of a nice deal. Gives me hope for the whole thing. And we'll pick up there tomorrow, 2 to 4:30 p.m. Eastern Time, 6 to 8:30 p.m. UTC, and have a good evening. Thanks for your help today. Bye-bye.